Okay, so the next thing we want is the second derivative, and we want to find the concavity and the inflection point. So let's go to a sheet. I pulled it up on a new sheet because we need lots of room for the second derivative. So let's use our quotient rule to find the second derivative. All right, so we're going to have the derivative of the top, which is 2x plus 6. And the bottom will tag along. Now we need the derivative of the bottom, so we'll have to use the chain rule here. 2 times the front. Lower the exponent. We now have it to the first power. And the derivative of the inside is 1. And now we need the top to tag along. And hopefully, I'm running on the edge of the sheet here. I can get it all on here. And all of that goes over the bottom squared. So we'll have x plus 3 to the 4th power. Okay, so now let's do a little bit of factoring to make this a little bit easier. Notice there's an x plus 3 squared here and an x plus 3 to the first right here. Let's pull out an x plus 3 to the first. We could probably pull out a 2 as well, but we won't bother with that right now. It's going to simplify it enough to get that x plus 3 out of there. All right, so when I pull that out, I'm left with this 2x plus 6. And I still have one of these x plus 3 since this was squared here. I've got a minus 2. This x plus 3 got pulled out, and I have that left. All over x plus 3 to the 4th. And now that I've got that x plus 3 factored out, I will go ahead and cancel out or reduce one of these. All right, so now let's multiply everything out that's left in the top. So if we FOIL this out, we'll get 2x squared, 6x, 6x, and 18. And if I distribute the negative 2, I'll get negative 2x squared. Well, this is going to turn out nicer than I thought. Negative 12x and 22. And then our bottom is x plus 3 to the 3rd power. All right, and the reason I said it's nicer than I thought is that these are going to cancel out, and it looks like the x's are too. 6x, 6x, and negative 12x will be 0x. So we have 18 and 22, which is 44, or sorry, 40 on the top. And x plus 3 to the 3rd on the bottom. Okay, so that means there are no critical values that come from setting this thing to 0. However, we do have that the denominator is 0 at negative 3. So the only thing we're going to put on our sign chart is negative 3. Now, if I put something to the left of negative 3 into this derivative, let's say a negative 4, this will be 40 on top. A negative 4 down here will be a negative on the bottom. So positive over negative, this is negative. If I choose something over here, let's say 0, if I put 0 in the bottom, it's going to be positive on the bottom, positive on the top. This is positive over here. So our concavity, this is concave down from negative infinity to minus 3. And from minus 3 to infinity, it is concave up. All right, now we have, I believe, 2 questions left to answer. Oh, inflection points. So in this case, negative 3 cannot be an inflection point, even though the concavity changes, because this is where our function is undefined. So we do not have an inflection point here. And I would assume that we would just put D and E in, because we do not have one. Let's just double check it. Yeah, that's what they're wanting, is D and E. Okay, so let's go on to finding the vertical asymptotes and any slant asymptotes. So for vertical and slant asymptotes, we're going to go back to the original function. Vertical asymptotes are fairly easy. That's where our denominator is equal to 0. And of course, we've been saying all along, this is undefined at -3, and that's because that's where the bottom is 0. So x equals -3 is the vertical asymptote. Now the slant asymptote is not as easy because we have to do some long division. We're going to divide x plus 3 into x squared minus 3x plus 2 using polynomial long division. And let me use another sheet because this is not going to allow me to go much further on the bottom. So we're going to take our original denominator, x plus 3. We're going to divide it into our numerator, x squared minus 3x plus 2. So we begin by just thinking about the first term here as we divide. X goes into x squared x times. And we multiply that back. X times x is x squared. X times 3 is 3x. And then we subtract, so we have to change our signs, negative and negative. X squares will cancel out, and then this will give us negative 6x. And we bring down our next term. And we divide again. X into negative 6x will go negative 6 times. And then let's multiply back. Negative 6 times x is negative 6x. And negative 6 times 3 is negative 18. Now we subtract, so we have to change signs. And we have 20 left. Now our slant asymptote, or at least most of it, is sitting right here. It is y equals x minus 6. So our slant asymptote is a line. Of course, that's an equation of a line.